Okay, lesson 1.1.3, what can I do with functions? Basic inverses, function operations. Lesson essential question, how do we combine functions using a variety of operations? Again, a lot of this will be review of Algebra 2, but there will be some new things here. First, though, we're going to talk about inverses and Anita. At right is a picture of Anita's function machine. When she puts a 3 in the machine puts out a 7. She puts in a 4, the machine gave her a 9. She put in a -3, out came a -5. Explain in words what the machine does to a number. Now in Algebra A, you learned about how to do this by hand, and that's great. Okay, but again, the other day in class, I hopefully showed you some tricks on the calculator, and this is one of those times where you have that opportunity to use the calculator and be able to do this a little bit faster. All right, so let's go in here. I'm just going to clear some things out just to make sure everything's ready to go. But in the stat, edit. Now again, to clear your list, highlight the list number, hit clear, hit enter. Clear the list, highlight the list number, clear, enter. Now again, type in your x values into L1. So she put a 3 in, so 3. Okay, she put 4 in, and she put in a -3. Okay, and then what came out? Well, when she put the 3 in, out came a 7. All right, when she put the 4 in, out came a 9. And when she put the -3 in, out came a -5. Now I realize most of you probably could have done this in your head, and that's fine too. But again, I want to review this method. So stat, calculate, linear regression, enter. Tell it where to look. So second L1, comma, second L2, enter. And we get our equation, y equals 2x plus 1. So y equals 2x plus 1. All right. So explain in words, it's multiplying my number by 2. So my number times 2 plus 1. Now, suppose it were possible to turn the crank the opposite direction, causing the machine to pull 7 back up into it. What do you think will come out the top? A 3. Suppose Anita wants to build another machine that will undo the effects of this function machine. That's called an inverse. And you learned about that in Algebra 2. So if we're doing an inverse, probably the most basic way you learned it in Algebra 2, at least the way that I teach it, is I start the same way, my number, except I'm going to undo. So I'm going to reverse the order and reverse the operation of what I'm doing. So it's going to be my number, and I'm going to reverse this. So it's going to be -1. And then opposite of this, divide by 2. So the inverse of this equation will be y equals my number -1 divided by 2. Consider the function f of x equals 1/2 x plus 6. What steps are necessary to undo this function? Well, write down the steps of the original function first. So I have my number times 1/2 plus 6. So I flip the order and I flip the operation. So now it's going to be my number, and I'm going to -6, and then I'm going to divide by 1/2. So if I write the equation of that, I would have f inverse of x equals my number -6. And then instead of dividing, I can write divided by 1/2, but fractions inside of fractions are a math no-no. So instead of dividing by a fraction, hopefully you learned at some point, probably 6th grade, it's better to multiply by the reciprocal. So the reciprocal of 1/2 is 2. So my inverse function would look like this. 2 times the quantity x minus 6. Here are some other operations with functions. You can add them, you can subtract, you can divide, you can multiply. And then we also have this thing here called function composition. And we'll learn a little bit more about that here in a minute. This will be a great opportunity to push pause and copy this into your math notes. Now, some practice. Given f of x equals 3x minus 5 and g of x equals x squared plus 2, find and simplify the following operations. So we'll start with the easiest one, addition. So I have f of x plus g of x. So I take my equation for f of x, which is 3x minus 5, and I'm going to add it to my equation for g of x, which is x squared plus 2. And this is nothing more than combining like terms. So x squared is its only like term. 3x is its only like term. And then I have a negative 5 and a positive 2, which makes minus 3. So f of x plus g of x equals x squared plus 3x minus 3. When you're simplifying this, it doesn't necessarily mean you're going to get an answer. You might not get a numerical, an integer value, a decimal value, whatever. It still might be an equation. Most likely it's going to be because we're adding two equations together, which will result in another equation. Let's try letter B, which is multiplying. So now I'm taking f of x times g of x. Okay, parentheses are necessary here. So f of x is 3x minus 5. G of x is x squared plus 2. This should be review of algebra B. I have two binomials multiplied by each other. The way that I will do it, and the way that you should also, is using a generic rectangle. So I have 3x and minus 5, x squared plus 2. And this is an area model, so I'm calculating length times width of each. So x squared times 3x is 3x cubed. X squared times negative 5 is negative 5x squared. 2 times 3x is 6x. 2 times negative 5 is negative 10. Like terms, there are none. So my final answer here would be 3x cubed minus 5x squared plus 6x minus 10. Does the order you write them in matter? Not necessarily, but it is most accepted to write them in order from the highest ordered exponent to the lowest. So 3 is the highest exponent, then 2, then 1, then no exponent. I'm going to go ahead and clear this, so if you need to rewind to see that again, you may do so. Part C, this is function composition. Now I have f of g of x. Before I begin this, I want to ask you another question. I want to know, if I ask you what is f of 2, what would you do? Okay, well, I hope you would plug 2 into the equation everywhere there's an x. So I take my equation for f of x, whoops, and I'm going to plug a 2 in place of the x. So 3 times 2 is 6, 6 minus 5 is 1, and I would get an answer. Well, this is no different, except I'm not going to plug a 2 in, I'm going to plug g of x. Well, what's g of x? G of x is an equation. Okay, so just like I substituted a 2 here in for the x, I'm going to substitute an equation in for the x. So f of g of x equals 3 times something minus 5. Well, what is that something? That something is my equation for g, which is x squared plus 2. And then I would simplify. So distributive property. Okay, so 3 times x squared is 3x squared. 3 times 2 is 6. Okay, minus 5. So 3x squared plus 1 is my final answer. That's function composition. Let's review that with letter D, which is g of f of x. So now I'm doing essentially the same thing, except I'm reversing. Now I'm substituting f into g. So same process. Write the g equation. So something squared plus 2. It would have been an x squared, but it's not now. Now it's f of x gets substituted in there. So I'm going to take my equation for f of x, which is 3x minus 5 squared plus 2. Now you could simplify this by squaring this. Hopefully you don't think that's 9x squared and 25. You would have to use a generic rectangle here and do 3x minus 5, 3x minus 5. Or you could do Mr. Warner's shortcut. Mr. Warner's shortcut is square, double, square. Well, what does that mean? Square the first term, 9x squared, double the inside product, so negative 15x doubled is negative 30x, and square the last number, which is plus 25. Square, double, square. All right, and then simplify at the end here, so 9x squared minus 30x plus 27. Moving on. Suppose that f of x equals x cubed minus 4x. What are the roots? Also called the zeros of this function. So this, again, we're still algebra B, still review. So So if I'm finding the zeros, I'm letting it equal 0, x cubed minus 4x. What I would do is factor this first. Both of these terms have an x in them. So if I factor an x out, I'll be left with x squared minus 4. X squared minus 4, you should recognize that. That's the difference of two squares, which means it can also be factored into two binomials. So x squared minus 4, 4 can be written as 2 squared. So that's going to give me x plus 2, x minus 2. All right. Then I'll let each of these equal 0. So 0 equals x. 0 equals x plus 2, so x equals negative 2. 0 x equals x minus 2, so x equals positive 2. Those are my roots. Roots are x-intercepts. So 0, 0, negative 2, 0, and 2, 0. Sketch the graph of f of x. So start with your intercepts. So 0, 0, negative 2, 0, and 2, 0. You can use your graphing calculator to determine where those high and low points in between are going to be, because this is a type of a cubic. So let's see here. I have x cubed, all right, minus 4x. All right, I'm going to go zoom 6. That gives me my standard window, which is what I want for this particular problem. And instead of guessing where these points are, just go second table and figure them out. So I got negative 1, 3, positive 1, negative 3. Okay, so I can go back to my graph. Negative 1, 3, positive 1, negative 3. And that gives me enough points to get the general shape of my function. If g of x equals f of x plus 2, how would the graph compare? Well, this is inside parentheses. Remember from yesterday's lesson, inside means two things. It means opposite and it means horizontal. So it's going to go left 2. Every point moves left 2. Every point. All the points go to the left 2. Okay, so my shifted graph will look like that. Sketch the graph of g of x. We did that. We did that. Sorry, this was left 2. Now, find an expression that represents g of x. So I'm going to take f of x, and I'm going to plug x plus 2 in place of the x's. This is function composition as an application in a graphing problem. So copy down, again, this is the trick that I try to show people, okay? G of x is nothing more than f of x with an x plus 2 substituted into it. So copy down f of x. Okay, but leave empty spaces where the x's are. What am I plugging into those empty spaces? I'm plugging in my shift of x plus 2. Okay, and moving on. Last problem here, this is a little intro to chapter 2, a little ahead of time. But how far did she walk? Megan went walking for 2 hours, and she walked at a steady pace of 3 miles per hour. How far did she walk? Okay, well, distance equals rate times time. That's an equation from science that you should know. All right, and her rate is 3 miles per hour. Her time is 2 hours. This is called a unit analysis. Hours cancel out, which means distance ends up being 6 miles. All right. Make a very careful graph of the situation where the horizontal axis is hours and the y-axis is the rate, miles per hour. Okay. And because her rate doesn't change, I'll go ahead and label your axis. Doesn't matter to me how you do it. So let's say 1, 2, 3 hours, and let's say 1, 2, 3 miles per hour. So she goes 3 miles per hour for 2 hours. That's going to be a horizontal line because her rate doesn't change. It's the same rate the whole time. Okay. Now it's telling me to you should get a rectangle for the area under the graph. So if I would drop a vertical line down here, you see that this forms a rectangle. Now part C is asking me to divide that rectangle into 6 smaller rectangles by drawing vertical lines at the 1 hour and 2 hour marks and horizontal lines at each mile per hour mark. So this is just a graphical representation of how we got this answer. Each one of these blocks represents 1 mile. So how far did she walk? What are the units of each side? 1 by 1. So each of these are worth 1. You add them all up, you get 6 miles.